second session of OpsMill Uncut. So today I have with me Wim and Alex. I'll let you guys quickly introduce yourself.
Hey, my name is Wim van Doorn. I'm a solutions architect and product manager at OpsMill.
Hello, I'm Alex, and I'm a solution architect at OpsMill.
Great. So they're both, so the topic of the day today is we want to talk about the schema. So I know there's been a lot of questions on, what are the best practices and what we can, what we should do and not do. So hopefully we'll be able to get to that. But we're going to have to start, I will say, from the beginning, and hopefully we can build up to some of the more advanced use case. If we don't have time to cover everything, we'll do another session. Love to talk about the schema. So maybe as a very, very short introduction, if you're not familiar with Infrahub and what we do, the concept of Infrahub is that it's a data management platform that is really tailored for infrastructure automation. The goal is to store all the data that defines like the internet set of the infrastructure. And then because we believe that in order to be able to be a good data management platforms, it's super important to have the flexibility and the ability to store any type of data, because as you need to automate more elements, as you need to automate services, it's super important to do that. So one of the key features of Infrahub is that when you start it, and that's what I'm going to do right away, it pretty much doesn't have any schema out of the box. And I'll say it's been our strengths and our weakness at the same time, because as often we hear people like kind of getting stuck on, okay, what do I do now? Like it's I started it and there's too much. So the goal of this session is actually to walk through what is the schema, how does it work, talk about some of the specific things and features we have implemented in the schema, and then again walk up to best practices and all. So there's quite a lot of things to talk about. So what we have here on the screen is I just started a very simple repo. There's really not much. It's pretty much like we just created a UV environment. We installed the Python SDK. So we won't go into the details of that today, but that's what's required. Because we wanted to make it fun, we decided that we're going to use the 1.3 beta release. So it's going to be released in a few days now, in a few hours even. But I feel like we wanted to use that. So that's why here I'm using a non-release version of the SDK, and we also have a Docker Compose to start the version of Infrahub. So with that, let's get started. So the first part is to start Infrahub.
So before we continue, I think there's a small technical issue, like not the whole of your screen is showing them.
Okay, then let me know. Is it better this way, or
can you make it a little bit smaller?
Even smaller? Okay.
The window, right?
It's at the bottom. It's like the bottom is cut off a slight bit. Yeah.
Yes, thank you.
Perfect.
Okay, that's fun. So we'll have to do the same, I guess, here. Good. Are you seeing the top as well, or?
No.
Yeah.
Now we do.
There you go.
Thank you.
Okay. Thank you. That's why we have a team here. So here, just gonna start the fresh instance of Infrahub, and then we'll get started. So we're brainstorming a little bit on what would be a good example for the schema, and I think we decided we were gonna go with something probably that everybody's familiar with, and that at the same time is also simple. So I'm just gonna bring that here. So here it's kind of put a checklist of a lot of topic we could talk about, and we're gonna try to check them as we go. If you have more topics, again, please let us know in the comments. Our goal is to we're going to try to answer them or add them as we go. But here's the first list. So in terms of what we're going to talk about, I think we discussed that we're going to try to be kind of classic and try to start with a device, talk about how do we model a device, and then we'll have the notion of site that connect to that device later on, and then interfaces and a few more things, but we'll talk about it. So at a very high level and simple, I would say that's some of the simpler design we can do. So the goal will be try to work through how do we build that and explore some of the specific features we have in the schema related to that. So with that, let's get started. So just to show here, now if I go to 8000, we have so we have a fresh instance of Infrahub here. If we check here, we see that it's running 1.30 bit.5.
Same issue, Damien. The window is not completely showing, sorry.
Thank you. We're gonna have to fix that. Thank you very much. Cool. So here, 1.30 bit.5. And so by default, there's no schema. And so what we're going to do now is we're going to create our first schema, load that schema, and explore some of those features. So the way it works is we need to define the schema in a YAML file. So I have a very simple example here. Guys, please feel free to join and help me. So we're trying again this new thing. So Alex and Wim are actually have access to my VS Code, and they can. So there's two things that either they can help or they can make this a very painful session. So depending on how they feel today, I guess we'll see about that. So the very high level for the schema, the way it works is we need to define the specific version structure that is defined into the documentation. But the main thing is every node that we define in the schema needs to have a name and a namespace. And then we'll be able, for example, to define an attributes. And these attributes needs at a minimum to have a name and a kind. So here, if I define the name of the device, for example, this way, so that would be like the very, very minimum things we need in the system. So let's start with that, and then I guess we'll build from that. Cool. So to load the schema, the way it works is we're using the Infrahub CTL command, and there's schema load command. And so here we could pass a directory, we could pass multiple files. So here I'm just going to pass the entire directory that I created. I also have the ability to do a check. So
actually, I think we should introduce our first best practice here when you start exploring schema, which is to create a branch in Infrahub. So I would advise you to create a branch, Damien, and load your schema that way. Yeah, the reason why is if you screw up your schema, you want to be able to revert the system back to its initial state. And with branches, we can do that quite easily.
Awesome. Yeah, thank you for that's actually perfect. So here I'm using Infrahub CTL to create a branch. So I'm just going to create branch 2 in this case. I guess I was not in the right environment. So yeah, thank you, Max. It's a really, really good reminder. So again, we haven't talked about it, but the first feature of Infrahub is that the schema is very flexible. The second main feature of Infrahub is that we can create branches. Like if you're familiar with Git, the concept is very similar. So here now we have a second branch that was created. And I think what's really cool is we can have different schema per branch, as well as different data.
So we have one question already from Claudia. Can you talk a little bit more about the namespace What's the function of the namespace? Is it a location? How should we think of it?
Yeah, that's a great question. So I think initially the namespace is actually, there's two reasons for the namespace. The first one is there's a set of namespaces that are protected and that we're using internally in Infrahub. So you can see here, there's a lot of the features that we use, like we have the proposed change, the profile templates, and a lot of things that we manage internally. So those are not like course, they're not where you will store the data, but it's more like the features that the platform provides. And for those objects, we have some restricted namespace. I believe if we check the doc, we should have a list of maybe I'm going a bit further, but actually it's a good point. Not sure if it's in the doc, but we are restricting the number of, so for example, we have core, we have internal, I think now we have templates. So there's a set of namespaces that are reserved for Infrahub. So it's a way for us to differentiate that. Now, when we introduce the concept of namespace, we're also envisioning that at some point we're going to need to introduce the concept of packages, where we would be able to have multiple different packages that are available online, and kind of like the same as what you can do with pip, for example. That would be a way to differentiate if two modules or a package created a schema called devices, then they will not conflict with each other, for example. So that was the mindset of the namespace. But yeah, you're right that today how exactly you should use them hasn't been. What we're seeing today is customers, they usually create namespaces that are more like about, is it going to be DCIM? Is it going to be circuits? It's kind of more like functional group, but in the future, that's probably going to evolve into more like where you will have the name of the customer, for example, as the namespace. Thank you, Alex, for sharing the link.
No problem.
So back to, so we created the branch, we go with the schema, load schema, and so here, so every time we use infrahubctl, pretty much every single command support the branch. So here I just need to say, I want to load this schema into branch 2, and so it will automatically load that. Here I didn't have to put the credential because they are already defined in environment variable. I'll just show that here. So that's why I didn't have to worry about all of that. But if you're using it, you need to define either the username and the password or some form of token. And so now that we loaded that, I just have to refresh the front end and then automatically have this device created. And we can see that just by adding the loading the schema, then I have a full UI that is available for it, and I can create my device. You can see, for example, that right now it doesn't look like much. It just has a name, and it has this automatic, what we call the display label that is being automatically created, sorry. And we can see also that we can automatically query, like there's automatically an infra device query that was created into the GraphQL API. So it's not the goal to cover all of that today, but just to show that every time we update the schema, those also gets updated. So here I'm able to query my device. So with that, let's start to dive in a little bit deeper. So guys, what do we want to tackle next? What would you have at this point if you were working with a customer?
For me, I would think like maybe a role. I would, give every device a role to indicate the function of the device in my network.
So great. So then I guess that introduced the concept of what is the kind on an attribute. So for example, if you wanted to create a role, I would assume you have a predefined list of roles.
I guess so. Yes.
So in this
like
case,
a router or a switch, or I don't know.
Perfect. So in this case, we have, so the notion of kind is really something that define like what is going to be stored in these attributes, and they will define a lot of things from validating what we get when we actually create the object or create the node. But it also define how this node is represented in the front end in many ways. So for example, so the list of available kinds is listed in the documentation. So if I go here, the schema. So here it's all the different kinds we have for the attributes. So from the text, number, we have the text and the text area, for example. So the text area, it will be like more of a large blob of text in the front end, and there will be like slightly different behaviors. We have date time, drop down, email, password. So, and the list keeps getting updated. And so here, if we do the choices, you guys remember the
router or
the structure, or at least I always forget the how we define that. I guess
name, label,
color.
I think there's color as well.
Yeah.
We need some HTML color here.
And a description.
So yeah, the benefit of using a drop-down is that we can define like some color and
So Claudia asks, are images supported? I don't think we have a kind for images at the moment.
So we'll just go with that. So here, actually, if we update the schema, that will create a migration. So I think here we should provide kind of a default value and say that router is the default value. So this way, because we already have some data that exists, it will not complain, and it will just add the router to the existing device. So here I loaded that. So let's quickly check how it looks like now. Nice. So I have my device. It has, because it didn't have it previously, now it has a router defined, and I can go here and create a second device and define that this time this one needs to be a firewall. So that was the adding of the role. So there's different kind of attributes. I personally would think that is already annoying me is that, you know, this long definition or this name that we have here. I found that very annoying. Knowing that, you know, this object has a name and all of that. So here is what we have, the display label. So the goal of the display label is that we can define how this object will show up in the front end. So here, if I say the display label is just the name of the object and reload that, then hopefully that should fix that.
Can you hear me, by the way?
Yeah, we
yes.
can.
Yeah. So Claudia asked, are images supported as attributes? They're not at the moment, but is it something that we could look into?
Yes, we can support images we can support SVG images in the artifact, but not as attributes. Yeah, we could definitely look into that for sure.
Good.
Cool. Let's maybe move forward. So what else do we have on the list of things we wanted to cover here? Loading schema, display label, attribute kind. I feel like we almost cover, I think, the basics of that. So should we maybe as the next one would be, I think we wanted to have a platform, right? Guys?
Yes. So a platform to, you know, indicate maybe the operating system on which this device is using.
So in this case, that would be an enum or?
Yeah, or a dropdown to begin with.
Okay, I guess let's go with a dropdown. So if we do another dropdown, and then in this case, the platform could be like June. I like to use the platform from NetMiko personally.
So
I guess that's where the label gets handy, is that we can just have a more friendly name.
So Claudia's got another good question saying, is the default value required? What would happen if you add a new attribute if there's already data in there without the default?
So if you make it optional, so that's a great question. So actually, let's go with this one. I guess it's a bit of everything. But here, if I define that platform is false, optional false, which means mandatory true. I guess we're always conflicted on this one. Me trying to load the schema, it should refuse that and tell me like, hey, I cannot create an attribute that is mandatory because I already have 2 objects in the database and I don't know what to do with them. So that's what this system tells me. It's like, hey, there's 2 objects. If I actually remove those objects, that would work. So if that was totally not planned, but one of the features we actually added in 1.3 is the ability to bulk delete. So let me try that. Cool. So now if I do that, it should actually, because it's going to check and say, okay, there's actually no object. So now you can add a schema with an attribute that is mandatory. But if you had an object, then we would have to provide the default value. So hopefully, Claudia, that answers your question. It's just because we have all the data to manage in the background, like maintaining the consistency of the data is always the primary goal for us. Good. So now we have the platforms, we have the site.
So now, like you mentioned, Damien, like I'm storing the NetMiko driver there, and like maybe what do I do now if I want to also store the Napalm driver, which might be different? How do we start tackling that?
Yeah, that's a good. So maybe before we go there, just looking at what we have here, I think there's a problem of ordering. So maybe we can fix that first.
Yeah.
So we have this concept of order weight that is built specifically for that. So that's actually a way that we can control exactly how the fields will show up in the front end. So if I go back here, load into the branch, then hopefully now if I had a device, I have them in the right order. Cool. That works. Probably should have picked different colors. Good. Awesome. So yeah, let's move maybe to adding other type of node. And so Wim, you were suggesting we go with the platform. Let's do that.
You just did, right? But what if I now want to store additional information? Let's say my platform, you defined the name to be the NetMiko driver, but I also have a Napalm driver that I would like to store. So would I go and add a new attribute, or?
I personally, in a case like that, I would actually create a new node. So I will go down and I'll say, okay, we're going to create a platform, for example, and we're going to define a set of attributes on its own. So I guess we'll have the name. So let's do it quickly. And then we could have another attributes that would be NetMiko driver if we wanted to something like that. Does that sound correct?
That looks good.
And then I would add, so in this case, I would probably remove the platform as an attribute. So here it's actually a good place maybe to start talking about how do we remove attributes. So here in this specific case, so we have this notion of state. So we can do it either at the node level or we can do it at the attribute level. But we have the ability to say, okay, I want to make sure that the state of this attribute is absent. And that's the way where I can, it's probably good to remove it here. So if I load this schema, just looking, two things will happen. Is the first one, it would add this new node right now that just exists on its own. And then it will remove the platform from the specific schema. So let's do that. And I didn't show it, but there's actually a way where you can see the changes that will be applied to the schema before loading the schema, which would probably be a best practice to do that. So we see here we removed the platform attribute. So that worked. I'm just gonna, I guess, remove it from here as well. So if I loaded the schema once, then I can remove it from my local schema. It doesn't matter. We're looking into how we could make the whole schema a little bit more idempotent, not idempotent, sorry, declarative, in a way that just removing it from the YAML will actually remove it from the servers, but there's also some downside to that or side effects. So for now, we have a more like incremental approach, and so yeah, removing things requires to have those state absent flag. Perfect. And so now we're gonna create a relationship to connect those two nodes together. So actually, I never tried if reusing the exact same name is gonna work here. I guess it should. That's the fun part. I guess we'll see in a moment. So when we define the relationship, there's three main information to define. Is we need to define the platform. We need to define what is the type of peers that we have on the other side. So in this case, there will be infra platform. And the third one is we define the cardinality of the relationship. And here we define that it's a cardinality of type 1, meaning I will only want to have one platform defined for a given device. And I also need to define if it's mandatory or optional. So if I want it to be optional, I say it's optional. And this way, I have the options to create that for a device or not. So if I load that now, up. So here, now I have the ability to define a platform, and I can create a new object that is of type platform, and I could call that Junos and say that, Junos is the NetMiko driver, for example. And so here I'm back to I didn't define a display label, so it doesn't look great. And then I can create my device number 2, for example, and define that as it. So now I have a second device. So it's also interesting is we see here that when I click on the device, I see the platform here, but I don't have it right now in the list of, in this table. We'll talk to that in a minute. And I think the other point that's interesting is from the platform point of view, right now I have no information about which device is actually connected to me, apart from this audit trail here, but it's not the, I cannot just directly list all the Junos device. So how would you guys do that?
which one do we want to tackle first?
Either is fine by me.
Okay.
Yeah, I'll do the attribute, the kind first, like what the relationship type.
So can you speak to that? Can you?
Yeah, so you can specify the kind of relationship that it is to the node that you're currently on. So, for example, attribute, we'll add it in the UI under the detailed section. There we go, and we've got different ones there. So by default, I think it's the default one. By default, it's the generic
Yes.
kind.
Yeah, and by the way, that reminds me, we didn't even mention that, but there is a way that you can actually see the schema directly in the front end. Like it doesn't have to be all YAML. Like when you're an object, if you click here, click on schema, you will automatically take you, and you will be able to see all the different. So we can see the full schema, for example, here. And we can see the relationship that exists on device today. Platform is currently of kind generic, which as you said, Alex, is the default one. And we can see that it has a cardinality.
And swapping that.
Go for it, sorry.
Yeah, I was going to say the generic is very generic. It's quite open, but like changing that, for example, to attribute will allow the list view and the detailed view to have that information.
Yes. So the kind of the relationship, we'll talk more about the other one, but the goal is to change some of the behaviors, and we have that described in the doc. We had the attribute one. The main difference is that it will show up in the list view. So if we go here and that, up. So now if I go to my device, we see that we have the platform now that is showing up in the list view because we changed the kind of the relationship. Very cool. So, and how?
We do have one question, by the way. Does the state absent propagate to nodes from generics?
That is a great question. I don't know. Do you guys know?
I don't think it does.
I guess we need to try that in we need to try that. Sorry, someone's trying to call me. I will call back later. So let's get I guess as soon as we get to generic, maybe we can try that. I think it is a good question. I think the issue is the state. Actually, now that I think about it, state absent. If you do that on a generic, the generic will disappear. But if the generic is itself referenced somewhere else, then you will have an issue that say you have a generic that it doesn't exist that is being referenced on one of the nodes. So it's not going to cascade to the node, I guess. I think if you do absent on the generic, you would just remove the generic from the map and act as if it didn't exist at all. And anything that referenced that will just lead to an error. But we can try in a bit. Good. So I think the other points we want to talk about was how do we actually make the relationship what we call bidirectional, or make sure they also show on the other side. So in Infrahub, the relationship, they're by nature only one direction. And if we want to also have the same relationship that works on the other direction, we need to, so first we need to declare it here. And we need to define the relationship on the other direction. And in this case, it could have a different name. It could, could be mandatory or not. So for example, here we can say we want the infra device. And in this specific case, we want to say that because we have potentially multiple devices, that have the same platform. So we want the cardinality to be many. So from the platform point of view, there could be many devices. And so if we have that, I guess optional true, then that should now show us the relationship from the other side. Now there's a trick here, and I'm not sure if that's going to work. So now that we have this, we added this relationship many, so we see this additional tab, and here I can see the device. So it worked, but that was not, there's actually a trick here, and I think it's probably something I've seen a lot of people fall into, is there's this concept of identifier when we talk about the relationship. So if we go back to this schema here, when we actually look at the relationship, so we see here we have the relationship to the device, it's type generic, it has cardinality many. And so what's actually super important is this, what we call the identifier. And this identifier, if it's not provided, it will be automatically generated for you. And in this case, when it's like simple relationship node to node, we make it that, you know, it always match on both sides because we just look at the name of the node. But in some advanced cases, when you have generic, when you have things like that, you could actually have names identifier that don't match. And in this case, then that could be very confusing because you could have two relationships that you expect to show the same information from both sides, and they technically don't show that. So, you know, I would say best practice is probably in the production environments to manually define your relationship and to actually, you know, just define them yourself. So it's the kind of things that's actually impactful because, for example, if I had a new identifier here, I believe it is not something that we are protecting today. And I can talk about the why.
No, you can change it, yeah.
So it's something that's actually you can fully change, but the result is if you do that, then now you do have, if you go to platform, it will show 0 devices. Even though if I go here, it will tell me like there is actually 1 device to this one. So that's kind of the some of the most, I mean, not most confusing, but sometimes confusing. Having said that, I think it's easier to have this flexibility this way, and yeah, just something to keep in mind. But if we wanted to have it matched, then we just need to make sure that the identifier on the other side matches. And so now what's going to happen is the platform will disappear from this one, which in this case will actually be a problem if it was a mandatory field, but here it's optional, so that works.
It was also pointed out in the comments, it's good to have the language server defined at the top for auto-completion for the schema.
Yes, very much indeed. Cool. So if we did that now, perfect. So expected the platforms to go away because I removed that. And so now if I redefine it, now a new relationship was created with the right identifier. And if I go back here, then now I see my relationship again. So, you know, check the identifier. I think that's the a really important rule, is that we're seeing a lot of users being trapped with that. Cool. So I see the time is running. So there's still a lot of things we need to talk about. So maybe let's try to speed things up. What's next on the list we want to talk about?
So I think if you want to expand on our devices model, pretty crucial is how do we start tackling interfaces? Maybe at a bare minimum first, and then we can dive into generics from there.
Or should we try straight from generic? Should we try that?
Sure.
Okay, so
that works as well.
So in Infrahub, there's this concept of generic, which I think is pretty unique. So this idea that here, for example, if you want to create a a new object. Let's call it infra interface and up. And they say that it's an interface has a name of type text, and it has a speed, for example, or what would be actually, I guess speed is
speed. M2
Role.
Let's keep it simple with speed. So the idea is like this interface doesn't, it could be many things. And if we wanted to create different type of interface, then we could also create, for example, what is the list of VLANs or the IP addresses and have all of those attributes as optional into this interface. But the concept of the generic is we can have this kind of defined as an abstracted type of interface. And then when we define the node, we'll be able to say, okay, we want to create different type of interface. One that is interface layer 2, for example. And so here, what we have to say is that we inherit from infra interface. And then we can create also layer 3 interface, which I think it's, so just that would actually make it possible for us to create interfaces. And what we can do here is we can create a relationship that defines that my devices has some interfaces. And here, because technically from the device point of view, I don't necessarily want to care if it's layer 2, layer 3. I have the option here to define the generic of the interface to define that. And in this specific case, I want to have potentially multiple interfaces. So I will define it this way. And my relationship will be, my identifier will be just my device to my interface. And on the other side, we need to define that all interface will be connected to a device. And we'll just say that there's only one device possible. And in this specific case, we want to make sure that the device is mandatory, so it's not optional. And that should work, right? Anything, if we load that, we should be able at least to create those interfaces, or?
Yes.
Let's try. So if we go to the devices now, up, now we see that we have the list of interface. And if we wanted to add an interface, now it's asking us, is it a layer 2 interface or layer 3 interface? And for now, it has the same information, just the name, the speed, and the device. But where it gets interesting is now we can actually start adding specific attributes to each of them. So for example, what would be a good native VLAN?
Yes.
So if we wanted a native VLAN to be defined on the, and make sure that it's mandatory option false. For example, the layer 2 interfaces will have a native VLAN, and I guess for the layer 3 interface, we could attach IP address to it. But we'll keep it simple for now because I think it will require to add, create the IP address and all of that, but it's probably beyond what we can cover in this session.
Yes.
So if I load that, so who wants to take on the parent component and explain that? I guess that would be the...
I think it comes down to we have the relationships now between a device and the interface, so we can model a device with its interfaces. But one particular thing that comes up is that an interface by itself is an object that should probably not exist in the database without a device. So if you create a device with its interfaces, ideally, when you delete the device, you would also want to be able to delete the interfaces together with that device. So, and to be able to do that, we have to provide additional context to that relationship. So today we're just, or what we are doing right now is just creating a relationship between two different types of nodes, but we don't give any additional meaning to that relationship. And for that, we have created a parent component kind of relationship that you can define. And what that really tries to model is that an interface cannot exist without a device. So basically, an interface becomes a component within a device. And that allows us to understand that those two objects, even though they are different types of objects and there's just a pure relationship between them, we understand that they belong to the same entity, which in this case is the device. So one other aspect that we will do with that, for example, is, as I described before, if you will delete a device and you use a parent component kind relationships towards interfaces, then we will delete all of the interfaces when you delete the device. So basically, as cascading delete will automatically be inferred for these kind of relationships.
Cool. So let's show it in action. So what you are showing, I think, to show the cascading delete, I figured maybe we need some data. So I just created this file that has been introduced recently that we can use to load some data. So I was going to do that. It's probably going to fail because I'm missing something here, but object load data device branch 2. Okay, so it tells me speed in mandatory. So here the idea is that we automatically check the format of this file and make sure that it actually is in line with the current schema defined for this. So you have automatic validation even before loading the. Thank you guys. So here I missed the speed. What else? I guess device is mandatory. Yeah, I guess it's mandatory because I didn't have. That is a good. I don't have the uniqueness and all that, so I guess we actually need to be a little further along to define all of that.
Can you quickly create a device in the UI to just?
No, I could create a device in the UI. I think the issue is that we didn't define any HFID and any of that. Actually, we haven't. Like the issue is, so maybe we need to unpack even more things here before.
Yeah, but like if we just create quickly a device in the interface, add an interface to it. Now that has the schema been modified to have the parent component?
I could just. So I haven't created I haven't added the parent and component relationship yet. Is that what you want me to do?
Yes.
Okay. So let's do that then. We'll get back to that, but yeah, we should definitely cover the HFID and all. So I think what Wim was talking about is here, we need to define the kind of the relationship as component, and then on the parent side, on the device side, we're gonna define it as parent. So now the platform will automatically understand that those two objects have a special relationship, and specifically when we actually load them on the forms and when we try to delete them, they will automatically have a specific, for example, if we create a interface of type layer 2, it automatically provided this device 1 now because it's, it's a component. Up. Oh, that is not. That's interesting. I guess we'll have to double check something here. So which one actually exists here? Device 1 or device 2? I guess there are 2.
I think you have to update the identifier on the generic for the relationship to the device to match with.
Oh, thank you. It's exactly the one I was like, we have to be careful about that, and of course I missed it. Thank you. Thank you. Good. I guess I need to load that. Okay. So now that's sure. So I think so that's some of the, hopefully explain the concept of the kind on the relationship, the concept of parent and component that are very important. They're also like parent component. They also are super important. So we're not going to be able to talk about this in this session, but maybe in the next one, when we actually want to create templates from that. So there's a way in Infrahub where we can say, I want to be able to create a template for like this type of node. And a template is a way that we can, for example, have a predefined type of Arista device with predefined list of interface. Then when I create my device, I just use that template and it will automatically create all those interfaces. So we actually use those parent components kind of relationship to understand what are the nested objects you want to create with as part of a template. So that's there's a lot of meaning to that. Now I think what's super important that we haven't talked about is uniqueness constraints and HFID.
Mm-hmm.
So let's talk about that. So the concept of the HFID is that in Infrahub, we want to be able to uniquely identify an object by a natural name that, like if we look at the object here, for example, we see that the object has a specific ID, which is here, which is very long, which is defined as a UUID. But technically, if I know that I only gonna have, or I can only have one device called device 1, then I should be able to define some uniqueness constraint. So the way we define that is either at the attributes level, we can define that something needs to be unique. So if we create that, then now I will not be able to create a second device that has a unique attribute. So if I go back here, so it doesn't change anything, but what's interesting is if we go now to the schema of this object, we can see that we also automatically created what we call the human-friendly ID. So the concept is, because we have defined that one of the attributes is unique, then we automatically infer that then the way to define, to uniquely identify this object using a unique name is actually to do that through through the name of the value of the name, pretty much. That's what it means here. Now the HFID can also be more complicated than that. So for example, in the case of the interface, we can define that the human-friendly ID would be composed of the name of the device, and the name of the interface itself. So we actually create like the combination of both, and that's how we're gonna uniquely identify an interface and make sure that we never have Ethernet 2 interface that exists on the same device, but we could have two Ethernet 2 interface on two different devices. So if
what is important here is that to be able to use a relationship in that HFID, it has to be required today. Like you cannot use it if it's an optional relationship.
Yes, that's a very, very good point. Is it loaded? Oh, perfect. So now that I loaded that, if I go back to my interface, now we see that the HFID has been defined in that interface as well. And so the implication, I mean, if you're just using the UI, if you're just using things like that, it's not super obvious, but where it actually makes a huge difference is when we want to start to interact programmatically, for example, with the device. So I have the ability here, if I want to create let's say if I want to create, or we have these functions we call Upsert for the layer 2 interfaces. So here I will have the ability to create an interface and reference the device, even though I don't know what is the, I'll try to do it quickly. I guess let's do the layer 3. It's going to be faster. Internet 4. So that's the name. So I guess I need to create the speed as well. Up. And then the last one is if I need to define the device, now I can define it, either I can define it with its internal ID if I know the internal ID, but if I don't know the internal ID, I could just say, I want it to be device 2. And that works because I have this HFID defined. And so does it looks good to everyone here what I'm doing, or?
Yeah, looks okay.
So here it automatically, for the first time, it actually created the interface because it's a Upsert. It's actually a way that it doesn't, it's like it's a very declarative interface that if the object doesn't exist, it's going to be created, but if it already exists, then it will be updated. And so here, for example, if I say, oh, actually, I made a mistake, the speed is not 100, it's 1,000 or 10,000, then I can run the same mutation. And what's going to happen is the ID is going to be exactly the same because the object, we're not going to create a new object. We're going to just update an existing one. So if we now go to the interface, we can see that here we have this interface for Ethernet 4 that was created, that was automatically created for this and managed through the Upsert. So it's why the HFID is actually so important, and it also helps with what I was trying to do earlier, like that didn't work, which is this this file. Those files actually heavily rely on having the HFID defined. So that's why initially it was not working and he was complaining and he would not want to create those devices. But now that we have defined the HFID on both subjects, I would assume it worked. Yeah. So now he was able to automatically understand, like, because we defined the HFID, because we define actually the parent and component type relationship and all of that. So we were able to now this CLI was able to understand that I need to create this interface and I need to connect it to the device and I need to give it those properties and so on. So yeah, so I think we're pretty much at time. I don't know if there's a few more questions we want to tackle, or was there any other question, Alex? I saw that looks like you were busy.
There are a few, and I think I've answered all of them.
Maybe let's try to repeat them quickly for anyone that.
So Claudius said, so one of the things that happens with ACI is, do you define one port and then it can be associated with one switch or many switches? So that I want interface 1/1 connected to a camera on these 10 switches, and camera requires specific properties. I can do that with the flexible abstraction. Has that come up?
So if you wanted one interface connected to 10 switch, I guess it's just that the relationship to switches will have to be of cardinality many.
Yeah.
And like where here in the schema, we define that the relationship to device is of cardinality 1. In your case, you could say, I actually want to have many. And you could also define like min and max. So you could say, I want maximum, a minimum 1 and maximum 10, for example, if you know that you should not have more than 10 devices. But if you have additional constraints, you could do it this way.
I interpreted that question a little bit differently. I thought like if you had like, let's say you had a common deployment method, you had 10 switches, all of them needed interface 1 to be connected to a camera. For example, I'd probably solve
that would be more like a template then. That's what you're saying.
Object templates, yes.
Well, actually, maybe the combination with profiles, right? Like if an interface
and profiles,
could be like if the properties of an interface are the same for what connects to it, like you could use profiles. Actually, I think that's the most powerful solution is probably a combination of both templates with profiles.
We haven't covered any of those in depth today, but we might in future.
Maybe that we need to do that for the next one. Any other questions?
There was one about, do we have a schema visualizer? So I sent some information about Emma, the app we can run alongside that has the kind of node visualizer, and they asked, would that come to the product? I said it's something we're aware of, but it's not something we're focusing on at the minute to visualize schema in like an interactive way, other than what we already have.
It's funny, actually. I was talking with someone this morning that suggested we should try to do like generate mermaid diagrams automatically so that we could visually represent the schema. I think that would be a great idea. So I'm sure there's many ways we could do a better visual representation of the schema.
Yeah. Another question that came up is said, why is the default to include the menu when you define a node? Because it clutters the UI, especially when you're using menus to define the menus YAML file to define the menus. I said it's a good starting point for most users, and after you've used it for a while, it's kind of in my brain when I'm working on a customer, for example. When I create a new node, it's default in my brain to include in menu false.
Yeah, that's a good point. Actually, I did it here, but we didn't really talk about it, that we can control how it shows up in the menu. And there's also a way that you can have a menu file that will let you control how things show up. So yeah, probably something for the next time also to cover.
Another answer to that is like previously there was only, you could only define it in the schema, and later on we added the possibility to use the menu files, right? So we needed to make that transition smoothly. So that is one way that we wanted to make that transition more easily.
Yeah, very good point.
Yeah. Someone's asked a question that we've not covered. If I want to create a branch and sync it with Git, how can I give it the credentials on the command line, or is everything in the UI?
So you can actually add. So what you need is you need to define your repository in Infrahub. So if you actually go to Git repository, when you add a repository, so either it can be what you call read-only or I guess the read-write. So here you can define an authentication. And right now we only support username and password. So everything you do in the UI, you can also do it in CLI. So I'm just showing it here because it's easier, but you could actually define it in, you could create a data file the way I showed it here and actually create your repository in this way. Or you could also, I think there's a CLI. I haven't used it extensively, but I think there's a CLI where you can do manage repository here.
Yes, there is. Yeah.
So I don't know if you can add the, yeah, I guess you can define username and password. So you can create a CLI also through, add the repository through, so CLI, object file, or GraphQL, of course. So all of the above should work.
Yeah, just to note, if you are syncing with Git, you probably want, if you create the branch, if you want to create the branch in Infrahub, you need the kind of read-write repository rather than the read-only.
Yeah, 100%. Cool. Any more questions before we wrap up, or? If not, thank you, everyone.
No, that's all of the questions so
Thank
far.
you guys for joining. Hopefully we covered, some good. I guess we were hoping we were able to go a little bit deeper, but I think there was good intro for maybe like newcomers to Infrahub, or even like people that are not there at the expert level. But yeah, I think there's definitely a lot more that we need to cover in the next session. So let's get it scheduled soon. Thank you everyone for joining, and yeah, let's continue the conversation in Discord. So if you have any more questions, yeah, we're always ready to help in Discord as well. Thank you.
Thank you.